Hello and welcome back to Compiler Programming. Today I want to talk a bit about and hopefully implement something with regards to default arguments and or partial application. So the language already has overloading, which means we can define the same function with different arguments. But we could also have default arguments. So should support default arguments. And one way we can do it is, let's just try it like this. So say test, it doesn't matter what it does, and we would say that you have x that is an S64, and then we have y that is also S64, right? So it has x and y. Again, it doesn't really matter what we do here. We can do nothing. That's perfectly fine for the purpose of this discussion. And so say we want to have a default value for y. What can we do? Well, there are a couple of things that we can be doing. The thing number one is to just add support for that in the compiler itself, and you then will be able to say something like y is S64 and it's equal to 42. This is quite ergonomic for the user, and it's pretty nice. It's also nice in that we could then take advantage of type inference, and we could do it like that, right? You could say y is 42, and then it automatically infers that it's S64. This is how, so like literals are inferred to being S64 if they assign to a variable. So this is exactly equivalent, and this is pretty neat. If we do something like that, then the type should be string, whatever, right? But doing it like this means that probably internally the compiler will become slightly more complicated. So this is option number one. Let's figure out what other options do we have. Well, one option is to not do anything. So let's get back to our original test. Let's call it compiler support, right? This is what we have. Now, another option we could do is to not do anything and just leave it on the overload side, because then what the user can do is that they can define another test, and that test is only accepting x, which is an S64, and it just forwards it to the next test. So we would say x, and we would say it like this, right? So now if someone calls x with just one argument, they will get this one, right? And if they call with two arguments, they will go here, and this one forwards to this one. So the benefit of this is obviously that I don't need to do anything, right? So we sort of already have default arguments, and you can make it that way. The problem with this approach is that it drastically increases the amount of functions inside of the compiler, especially if you have like different combinations. So imagine that you have like a few more arguments here, and you want to have an ability to have all options for all of them, right? So that means that you would have to have how many arguments are there, so many functions, and that's not great. So that will actually hurt the performance long term, I believe. And yeah, it just might be one of those things that is not worth it. In addition, in this form, we eventually could support named arguments. So we could say something like, when I want to call this function, I could say test compiler support of, I could even like do it in the wrong order. I could say y is 30 and then 10, right? And then x will be 10, or I could be very explicit about x. So we could do named arguments, and this is kind of neat, right? To be able to name the arguments, especially if the function has a lot of them. Right. There is also a variation of this version where these functions are generated automatically. Like we could have partial application support. So I could do something like, I don't know, this, where these two variants they're exactly the same, right? So this one just expands to this option, and this could work. This is way nicer to write than this thing, but more or less, it also would require some support from the compiler, because when we make a function call, it needs to know that if I'm using, for example, this underscore or whatever we decide the good syntax for partial application is, then this would be what needs to happen. Maybe like I can do like more explicit, where is a partial test, and then yeah, something along these lines, because this is way more explicit, but I guess less readable. So I don't know. So these are the options that are with the default arguments. And after thinking about it for a while, even though I do want to eventually have a partial function application because it has other benefits besides the default argument, I think I do want to at least try to implement this version and see how it feels like. And if I decide that I don't want it after all, then I will just remove it. I don't have any problem removing features from the compiler, as long as I realize that they are not necessary. But at this particular moment, actually not having it is kind of hurting some of the other features and readability in general. So I will go ahead now and implement this version. I will not do the named arguments. This is a separate thing that needs some thinking over of itself, because there is a question about how to do it. I don't like languages where you have named arguments, but you cannot spread them out or in out of the structs, right? If I have a struct with two fields that are exactly matching, this would be very nice if I could just like somehow spread it. Some struct with x and y. So something like this should work. I'm using here JavaScript syntax, but it doesn't really matter what the spread operator would look like. The point is, it should be possible to somehow make this happen. And right now, that's yeah. Not very many languages allow you to do that, and the ones that do are awkward as well. So I'm still thinking what would be the best way to support something like this, and until I figure it out, I will not do named arguments. I will be okay with just having default ones. Okay, so let's do it like that, and we can say we can have our test default. And here we do test. That will actually call our test default. So let's say that default will be, it also will return as 64, and it will just be x plus y. And in fact, ideally, this should work as well. Maybe we want to do it as a separate step, although maybe let's do it right away so we have a complicated test case actually. Because sometimes starting with a simple use case, simple test case actually hurts the implementation because you go in the wrong direction. But for example, this means that we would need to um, delay the evaluation of all of these until we know all the arguments, something along those lines. I'm not sure exactly what it will entail, but we can think about that. Okay. Yeah, another thing is that when we pass something in here, we first need to bind it to a temporary value so it's available inside of here. Yeah, well, let's see how it goes. So I want to do here a 64 and I will call test default. I will call it with 2, or let's call it with 20. So we should have 40 back, and then we would say plus, and then it will be test default with 1 and or 0 and 2, and we should get back 42 out of that. That seems reasonable. Okay, call it checker. Function type. Actually, here it doesn't matter. Here it's test. And then function type is void to a 64. Let's put it in here as well. Let's see if that builds. You're right, we don't need to pass anything. And we have actual is like this. Right. Okay, so the test case is in. Let's start failing it. And we'll see that we have a failed test. This is not a very good error, I would say, but well, it is what it is. Can I check it like that, I wonder? Right, okay, so it is failing. Yeah, because I'm using the wrong thing. It should use test program inline source function because that will actually report whatever error we have when we try to get the function. Right. So apparently not though. That's quite curious. Okay. Right. So we should actually do it that way, I think. Function is values function, or function type a pack function, return function, and then I should do it that way. Hopefully that doesn't break any other tests. It might. It didn't, but it also didn't help. That is very curious. Do we? Right, we do have ensure compiled function body. Okay, well, that is just dealing with tests. I can deal with that later, but it's interesting to know that we have somewhere a variant of an error that is not really cut nicely by the system. So, okay, let's get back to here. I believe I already have a couple of different function argument options, right? So we have already this concept of exact argument. I can try to find where it is. Exact, no. It was checked somewhere, although I don't remember exactly where that was. Yeah, here. So this is our exact argument. So we can put like a value into here, and then that value is compared against this one variable, and only if it is a literal of exactly that value, then it goes into this branch. Okay, so that means that we can just introduce a new one and say that it is default value or something like this. And an interesting question is, what is what is sort of the value of that? It definitely has a type, but actually even the type is kind of interesting in a sense. We need to evaluate the argument in order to know the type, but we don't know. That causes an interesting problem actually right now, because wait, maybe not. Right now, the way the inference works in the language is kind of clunky. It requires us to evaluate the expression in order to figure out the type of the return value. Like we have to go through that, and that might be a little awkward, to be honest. But we will just plow ahead for now, and then I will figure out later. Maybe I'll do a separate video on how we deal with not evaluating the whole expression to get the type. But I need to think about that a bit more. For now, I guess what should go into here is a token view. Something like that. And then we just evaluate it every time we try to go for it. Okay, where are we? What is this function? Oh, this is the most meaty one, which is a function call. I will probably leave it for the end, although, yeah, might as well. Try to handle this. Function argument default value. Okay. Right. So I need to think about some of the limitations around the function argument. So the first limitation is that it's a question whether an argument can refer to another argument that's defined afterwards. So imagine I had something like this. I have z that is 32, and the question is, can y return to z? And if I say yes, then I go into an interesting problem of resolution of what depends on what, and not getting into infinite cycles, because I can just do this, right? And that is trouble, because we are saying that in order to evaluate y, I need to evaluate z, in order to evaluate z, I need to evaluate y. So this is awkward. I could only allow this in one direction. That would simplify both the implementation right now, and also like just remove this problem altogether, although it will mean that some usages are just not not gonna work. But I think that is an okay trade-off to make, because especially if we allow to specify like allow named arguments, calls to named arguments, you can always reshuffle the arguments in the right order and make that work. So I think I will only allow you to refer to the previous arguments. So this is perfectly fine then, and that also simplifies what I do here, because I don't need to delay the execution of this argument to the point where, to the point where we know all of them. Okay, so we have arg value, and right. So this is another thing about right. So there are two options for a function called with default arguments, right? There is a version where we don't have one, and a version where we do have one. And in here, there can be either of these. So we need to actually have another if in here, and we need to say if I is more or equal to dynamic array length of args. So args is the arguments that we actually have, and function arguments are the defined arguments in the function literal that you wrote, function definition that you wrote. So if so this is actually, or use the default value, else use the user specified value. Maybe I don't need to have that. I will just say default value, user specified value, right? Okay, well, if it is a user specified value, then we kind of do exactly the same thing as we do here. So I could do some really funky stuff with the key statement and fall throughs, or I can for now duplicate it, and I just will write wrong place. I'll just write a to do copy paste from above. So I'll figure out how to extract this nicely. For now, it's okay if it's a copy paste. Okay, what do we do with default value? We obviously don't have one to get from the list of arguments that is applied to us, but we do have that token thing. So token view tokens, right? Or I can call it expression. And we can just evaluate that expression. We can say token parse expression, I think. And this would be right. So this is quite interesting because okay, this is a macro version of all of this, right? I will also need to deal with a non-macro version. So okay, if it is a macro version, then well, I guess for now I will just define this on the stack, even though it's not particularly great. So reserve stack, context allocator, and then function arguments. So this would be like arg default value descriptor. So we reserve some place on the stack. And then we parse the expression where we say arg, so context, arg. Context is also should be something different for that actually. So let's steal this piece of code because we don't want to evaluate this expression. So let me explain. When you're writing something like x plus a, right? You need to get an error where about a. Because if you have something like this, and you evaluate this expression in the context of where the call is made, then this would awkwardly work, and this is usually not what you want. This is not hygienic at all. So what you want is for this expression to error out, even if A is defined in outer scope. So you need to evaluate this expression in the scope of the function itself, rather than in the scope of the caller. Or rather, yeah, you more or less want to evaluate it in a special arguments scope of the function, not in the body of the function even. Okay, so do we have such a scope? We have body scope, okay, function scope, scope make. In case of a macro, I guess we can just evaluate it in the body scope. That's fine. Yeah, I guess that's fine. Context or arg context. Let's call it arg context. And you want arg value. Function argument default value. What's wrong with this? Because it should be tag. Right. Cannot convert from default value tokens, I guess. Or I called it expression, I think. Too few arguments for a call. Fine. What do you want? Yeah, you also want parse mode. That is fine. I can give the parse mode to you as well. That is okay. Right. So that's an expression. Descriptor star with compatible function builder. Okay. Context builder. Is it better? Okay. Good. So, right. We evaluate this argument here. I don't need to coerce it to the value, I think, for now. I'm also not even sure we always will have descriptor, but we will see about that. Okay, so that is the macro version of this. Let's think about all the other versions of this. Call function overload, right? So this is where we will need to fix that. But for now, well, let's just go through this. Okay, calculate arguments match score. Right. I'm starting to not really love this version that I did. So the idea here was that we would have different orders of magnitude between the various various type of matches. You have cast, you can have an exact match, you can have a literal match, and they have, yeah, as I said, like different different power. I can do it like that, so it's a bit easier to read. And now we need another match, which is the default match. So it sort of trickles downward where we have like default here, which is better than the cast. But then the question is, what happens when you cast to a default value? I guess it's still a cast. I'll need to think about that. Maybe I will need to rewrite this whole procedure. For now, I will just continue here. So type will now become this, and this will become this. I'm not even sure it's possible to use a LLU in here, but we should be fine for now. Okay, so that's an exact, and that's any of type. And here we also need to again deal with the fact that we might end up with less arguments than we have. Right. Okay, function tag default value. So source arg and target arg. Right. So I think what I will do actually is I will do it this way. So, sorry. We have target arg, and we need to have another if here, the same as we did there, where we say if arg index more equals to dynamic array length of arguments. And that means that actually here we need to go over descriptor arguments. So, right. If it is the case, then we need to say that if target arg interesting. Well, it's sort of the same thing, really, where it will be just a fake argument. Right, first things first. So if we have this, we need to verify that the target tag is not a default value, then we are out. We say return 0, or actually -1 is our thing where we say no, that is completely not a match. If it is a default value, then yes, we need to create a fake target value, although that will be slightly awkward to do. Well, again, for now, I'll just copy paste all of that. Maybe. Source arg. Okay, let's do it that way. Fine. It will be slightly inefficient, but that's okay. I can live with that. target arg, default value descriptor, tag any, yes, fine. So star source arg, not rage, arg. And here we say source arg is locator, allocate of context. Do I have a context here? I don't even have context, so I can't even allocate stuff here. Okay, let's not allocate. Fine. We'll just create a fake target value that we will reuse for purposes of on-stack comparison, where we would say fake target value is this thing, right? And then we would say that source arg is an address of that fake target value. Right. That seems reasonable. That won't build, probably. No, it will, because I made a mistake. I also need to do the same thing here. I might want to actually extract the descriptor outside of the tagged part of this union, so I don't need to switch on that to get to it, but that's okay. I can say target arg tag is default value, then you do this, otherwise you do target arg any of type. In reality, they are both in the same exact location in memory right now, so it will work either way, but it's better to be correct about this. Okay, does that make sense? Let's review. We have source arg. We're saying that if we don't have enough arguments, and if we actually have a default argument, then we create a fake value for the purposes of matching, and we try to match that to what we want. Seems fine, I guess. That should work out. Let's see what else do we have. Ensure compiled function body. Right. Well, from the standpoint of the body of the function, default argument is exactly the same as non-default argument, because any evaluation of default expression should happen at the call site, not inside the function. So like this x is sort of evaluated here rather than here. Like it's literally should be exactly the same. We are copying that. We should copy that expression into a temporary place. Then we put it in here. That's more or less how it's supposed to work. And we'll get to that in a moment. So for now, I will just say default value. In a sense, maybe I should, now that I'm thinking about it, maybe I will change how this stuff is set up. Maybe I will not put it in here. Maybe I will have it on the any of type. So this will be another field that is optional. I'm not sure. I need to think about that. For now, I guess it's okay. Any of type, yeah, default value also should have a name. All right. So how are we going to do that? Well, we say that slice name is argument tag is function argument tag function argument tag default value. Then we will put it like this. Okay. And now we can have our name, right? So from the standpoint of the body, nothing much has actually changed, and that is good. Enumerator function argument value at index internal. Well, that is the same. Default value. Right. This function just figures out where to put the arguments. Does it go into register? Does it go into memory? According to the colon convention that you have. Okay. What does this do? Same type. Well, it's more or less the same as this. We never actually yet compare functions for equality, but we will at some point, so it should work. This is also wrong. It's supposed to be something like that instead. And that means here it's break. Right, that was pretty bad to be honest, because it was comparing only the first argument, but as I said, we never really compare the types of functions yet. So that's, I guess, okay. Good, we are building, but if we try to run, nothing will change because we cannot actually parse yet the default argument. Yeah, we still have the same failure, and that is because we have no idea how to handle this thing. Okay. I think I will leave inference out of it for now, and I will just support this form and then figure out how to deal with inference later. And the place where this is going to happen is in the curse. No, it's a function literal. Right. So this is where we parse the function. This is the return type, and this is the argument. So let's look at that. Okay, and I'm going to look at a different place where we do parse assignment, because this is more or less what we are doing. All right. So if there is no assignment, then we do one thing. Okay. Right. Let me copy that. Maybe like this. And let's think what the logic should be. So first, we need to know if so we have expression or default expression, and we have definition. So if we were able to split on equals, then what? Well, first of all, we don't need that, and we don't need that. But so we need to say bool has default value something. So if we were able to split, then we say that is true. Actually, that should start with false, else. And then default expression, that's fine. They want to zero initialize it. I probably don't care. So if we were able to do this, then definition would be the left part of the expression. Otherwise, the definition is gonna be view. So the whole thing will be considered the definition. Okay. Once that is done, we actually, we don't care about what is inside of default expression. We assume that it is correct. We don't need to do any of that side. I guess I want to rename this into something more more readable. So this is type expression, and this is name expression or name tokens. This obviously will create a bunch of errors, but I think that's good. Right, we have operator, which we don't really care about. So we could do something like this, maybe. Yeah, we actually don't care about operator in either case. So I can remove it from here as well. It just cleans it up slightly. Okay, actually, apparently we do care for the purposes of error reporting. So let's leave it here. It's okay. All right, and now we have type expression and name tokens source. Okay, that seems pretty reasonable. Should have put this here. Okay, it builds, but it still does not do the right thing with the default, where we need to now say the following. If has default value, then we do something, otherwise we do what we were doing before. So that would be tag default value. We put it here, we have descriptor, that is the same, we have name, that is the same, and we have expression, which is default expression. This is getting quite lengthy, so let's split it up. Okay, so we are building. We should be getting into this branch now. I guess let's run the tests and find out how we are doing. We will still fail. My prediction is we will fail in call overload. Is it here? No. In here. So we actually will fail in here on this assertion. This is what's going to happen, I think, if everything else works correctly. Apparently not. Apparently everything just falls apart. Still in exactly the same way. That's kind of interesting. So what is happening then? Just out of curiosity, does this work or am I missing something more obvious? Oh yeah. This is definitely something to fix. So if I miss a /n here, everything falls apart quite badly. Now let's check this version. Okay, right. So let's put that back in. And now we should have an assertion. Apparently we don't. We get cannot resolve type. Right, that's because you need to work on the definition. Cannot find matching overload for call test default. Interesting. I wonder which one of them. So to test that, what we're going to do is we're going to try something nifty, where I would say like this, and then I would put, actually have not checked if it works even. So I'm kind of spreading it across two lines, and then we should see, based on the line here, which one is failing. I expect that it is one version, but it could be either of them, to be honest. Interesting. So it is actually this version that fails. So I no, okay. So this is the one argument one. Okay. Well, time to get our debugger and start looking into what the hell is going on. And which error again are we getting? We are getting could not match overload for call test default. I think that is happening. Right. So this is in handle function call where we are trying to match these things. So I guess argument score failed us. Well, we can try to look at what it did. Okay, so I need to find a better way to break on a specific test, to be honest. For now, I have to do this weird dance. Okay, so where are we? First, let's verify handle function call, check the target token. Target token is Fibonacci. Oh, what? Are we not even getting here? Right. So there is this check now, which I think needs to go away. It will be part of the calculate arguments match score. This was sort of an optimization, but it's no longer true. Okay, we actually do get to here. The first one is a regular argument. It is any of type. It can be cast, so that's okay. Then the next one should go into default branch. Yes, everything is correct. We get to here, we get to here, we again get to here. That's not right. Well, I mean, it will work, but it's sort of really bad what is happening there. So I will change how it works slightly. Where is it? No, it's the wrong function. It's this one. So I also want to have a fake source value. And then this is like this. Okay, that is slightly better because previous version was not particularly great. Let's just put it that way. Again. So cast for the first one, default for this one. We should have exact same type. We do. We are happy. We get to fall out of this stuff. And this is our score. It's not one. We matched. We try the next thing. There is no next thing. We don't have this one. It is not a macro. We go inside call function overload and all of this will be fine, but this assertion will now explode. Okay, good. So now the program behaves as I would expect it. Still not quite working, but failing in expected manner is almost as good as working. So let's work on this thing. First of all, we need to do it that way. So we no longer have this check. I wonder if I want to handle the default arguments on the level above or in here. This is something to think about because here it would be a bit more low level function that always expects to have them. I don't know, to be honest. Let's for now put them here and then we will figure out if that is a good way or if it is a bad way. Okay, source argument. So we sort of need to do the same dance as everywhere else, where we say that it's actually more akin to one that we did in match score. So this stuff. Except that the value is not at all fake in here. Instead, we are doing what we are doing here, where we are like that. We don't really need to have... In here we actually do know where it needs to end up. We hmm, that's kind of interesting. There is a bunch of logic to handle big values versus small values, and it's unclear to me if I can just use the target argument as the target. I don't think so. So in a sense, I do have to keep it that way for now. That should be the safer option. Fix me. Do not force the result on the stack. There is even more problems with what is currently happening. So X will end up being evaluated multiple times, which is not great. Actually, right now it will not be even available. Okay, let's take it step by step. For now, I will put it on a stack. That is okay. And we have executions. Right. So the question is, which scope will we have? And the scope of this will be the scope of the function, maybe. So scope star default arguments scope is scope make function context allocator function scope 0, something like that. I think I need actually the parent of the scope. Function is called descriptor in here, which is confusing, but okay. Descriptor function scope. Right, we don't need the second parent. Okay, so this is a default argument scope. This is not argument index, this is I. And then I need to have a definition of target arguments. Function argument value at index, right? So I need to have like values, not value, function argument star target argument definition is dynamic array get of descriptor arguments I, something along these lines. And then we can have it this way. Okay, so that is fine. In here, I think I can just assert, so I would expect whoever is calling this function to make sure that that is actually the case. Okay, we already talked about the stack. And here, I guess it's like this. Okay, the scope will be this scope. token parse expression, too few arguments for a call. Right, like this. Okay. And what was here before? Where was it getting the... I guess it's I, right? Okay. I do need to say that source arg is... Well, I can just use source arg here, to be honest. Okay. I guess we don't need these extra braces. That still will not work. Well, we can actually try to make it like this first and have a separate test second, because right now you cannot refer really to the X, but we can fix it in a moment. Let's see how we are doing now. Build and run. Well, that didn't work. We have a function whose scope is 0, so I guess I shouldn't do parent. Okay. Well, we have something. What is our actual? Our actual is not what we want. Is 26. How did that happen? .26 is such a weird value. It doesn't make sense from either side, to be honest. Okay. Let's look at what is happening there. So we are okay, we are calling it with 20. That is very wrong. We are missing the second argument there. Wait. What is arguments here? Right, that's a wrong thing to iterate over. We need to iterate over descriptor arguments. Let's try it again. Well, that's better. Are we in the right test? We are in the right test. So something did not work correctly. Okay. Well, what did not work correctly is me writing correct code, because that should be like this actually. We need to make sure that it is a default value, not that it's not a default value. Okay. Well, we did something. Let's see what we got. Look at it. We have 42. Great. That is a cause for celebration and intermediary commit. So 149 support basic default argument setup. There is a bunch of stuff that still need to be done. Some of it I will do still now, and some I will do off video. What I will do now is I will make that example arguments that refer to previous arguments. So this should work, right? Which we originally wanted, but it won't. At least I think it won't. So let's try to run a test and see what it says. Oh. So something funky is happening here. It should not find the X here. What if I do like MMM? Does it even catch that problem? Right, it does. That's the wrong place. So in here, I need to check that mass on error. Is it like this? No, that means it is going to be like this. Arc context result. That just avoids us doing a bunch of extra work. It doesn't really bring anything new. I'm slightly concerned about this stuff. So what is the scope where we call this? Context. Let's go to function literal again. Right. I don't think this is correct. Yeah, even in fact, I even have fix me. What if I try to do it that way? Ah, no. Okay. No, that's actually not weird at all. That's fine. I mean, it's useless, but it's fine. So it uses a current scope and it makes a scope for itself, and I assume it sticks it into here, right? So why does it find an X? Call function overload. So all of this just only happens when we are doing a macro. I guess when we are evaluating the body, we define it in the same scope. Ensure function. Ensure. Is it still here? Yeah. So what is happening here? Which scope are you using? Scope? No. I said sure compiled. Okay, let's quickly look. Scope define. Yeah. So that is not cool. That is not cool at all. We need to do the following. Scope star body scope is scope make of context allocator function scope. And then you need to define it here, 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 here. I guess that is all. Function scope. Okay, we only have it once in the file. That is good. I hope that doesn't break anybody else, but it might. Okay, it didn't break anybody else. The question is, did it correctly break this? I hope that it does, but you never know. Okay, now that's correct. We have undefined variable x. This is what I was expecting because we have not actually defined it. And I can do it that way. We have call function overload. And the thing is, once we have done this, at the very end, we take the default argument scope and then we define the argument. So the name, this is kind of awkward. Slice and name is 0. Actually, let's not do it. So we need to switch on the definition tag. Then it's all the same jazz. So name is target arc definition, default value name. If it is exact, then we have a 0 name, and here we say if name length. So if there is a name, we actually define, and what we define is we define the target arc. And here it's supposed to be, actually let's put it first because it's first everywhere else, and like so. Okay, now we should be fine, I hope, but we'll see. And we are. Okay, cool. That is probably all. Let's commit these changes, episode 149, and say allow default arguments to refer to previous values. Cool. So that is definitely a bunch of progress. There is some stuff with not creating unnecessary temporary values, which I need to think about, and there is other places where this happens as well. So probably most of it will have common solution that just need to be figured out and implemented. And there is stuff where during the definition of the function, I also need to add some check, like I need to not allow something like this to work, I think. It can technically, but it becomes very weird, so I think I will not support that. And this needs to be detected. Like if I define an argument and there was already a default argument, then you say, oops, that is not correct. But that can be done sometime else. For now, that's all. Thank you very much for watching. I hope you learned something new and enjoyed the episode, and hope to see you later. Goodbye.